Hello and welcome everyone. Thank you for joining us for today's webinar. My name is Abu Tayyib and I'm the CEO at Golf Business Technology, the leading technology news platform dedicated to the world of golf. Today we are presenting Foresight Sports, the Optical Advantage, presented by Tim Briand, who is the Director of Business Development, and Liam Mucklow, who is the Director of Education from Foresight Sports. And just before we get started, just a little housekeeping. The webinar is being recorded and will be made available after the webinar on the Golf Business Technology platform. Participants will be automatically muted and cameras turned off. If you have any questions during the presentation, please type them into the question box into the Teams Q&A panel. The questions will then be answered at the end of the presentation by both Tim and Liam. If you would like to ask any questions after the presentation directly to both, please use the raise the hand function and one of Tim or Liam will assist. Now, without further ado, we will turn over the time to Tim Briand. Tim?
Abu, thank you so much. Thank you to all of you who are spending time with us today to learn a little bit more about Foresight Sports and our technology. We appreciate you for everything you do, Abu, to keep us up to speed in the industry when it comes to technology, and look forward to spending some time with you here today to share with you some information. As Abu mentioned, my name is Tim Briand. I'm the Director of Business Development for Foresight Sports. Been with the company for about 3 years. I've spent my entire career in the industry in some form or fashion. Looking forward to spending time this morning. Without further delay, we'll get right into it. So I'm going to begin sharing my screen. Hopefully for all participants, you'll be able to see the screen, which is our presentation we're making this morning. So to get started, Foresight Sports. Who are we? First and foremost, we're one of the Vista Outdoor portfolio of brands. About 2 years ago, we were acquired by Vista Outdoors, which is a publicly traded company based out of Minnesota here in the United States that owns 42 different leading consumer brands across multiple different sports verticals and action sports. We're very excited about what this acquisition means to our company and business. You're probably familiar with one of our sister companies, which is Bushnell Golf. As we scale to meet the demands of the industry and the amount of growth that we've seen in the golf simulation and technology space, we're very confident that our relationship with Vista Outdoor will give us the resources that we need to meet that demand. When you look at the company, just some quick housekeeping to introduce the company and products to everybody before we get into the second portion of our presentation, which will be conducted by Liam Mucklow, our Director of Education. The company was founded in 2008. We are based in San Diego, California. We have about 220 of us these days, and over 100 of us are engineers. So at our core, we like to say that we are an engineering company. Something that a lot of folks may not be familiar with about our products is that before the creation of Foresight Sports, many folks are familiar with the GC2 launch monitor that was our first product we brought to market many years ago. That product was actually designed and commercially sold as the Nike G100 launch monitor. So we've got an extensive background in the space dating far past 2008, but once Foresight was created, 2008, we started shipping product in 2009. Something that a lot of folks don't realize about Foresight is that we are vertically integrated. You can see some of the assembly line right there for a couple of our products and the burn testing station for our GC3 product. So when you look at our engineering, manufacturing, and development, all of that takes place in that building that you saw on the previous slide. That's something we're very proud of. It's something that helps us keep control over the product and the manufacturing process. And then the next thing that I think is worth mentioning, that the level of industrial design that our team engages in, when we release products is second to none. You can see a little snapshot on the bottom right of the page. This was a unit recently from one of our PGA Tour players, multiple major winner actually, and you can see he's hit 46,000 shots on that device in just over 2 years. So the machines are very durable, and we're very proud of what we produce from our assembly line. As I mentioned earlier, many are familiar probably with our initial product, the GC2 launch monitor, which is up on the screen now. Again, 25 plus years of manufacturing and in technology experience. We have an extensive patent and IP portfolio, dozens of various patents on various applications. When you look at our utilization throughout commercial applications, we have over 50,000 devices out in the world currently, something that we're very proud of. And most of those devices all work to this day. You won't find very many electronics that are durable enough to withstand 10 years of usage outdoors, but that is something that our products boast. When you look at where you'll find us, we've had a lot of success out on the various worldwide tours over the last few years. When you look at utilization out on the various tours, out on the PGA Tour any given week, we'll find anywhere from 60 to 100 players utilizing our products. It's something, again, that we're very proud of. There are many different reasons, which Liam will get into in his portion of the presentation. Something to note is all of the players that utilize our product pay for the product. So it's not a case where we're seeding the marketplace or the PGA Tour. We've had that question asked a few times. When you look at the universities here in the United States as well as abroad, you'll find our technology in use by a number of the leading programs throughout the country. We'll get into the collegiate component in just a moment. When you look at the R&D the R&D divisions of various manufacturers as well as the governing bodies of the industry, you'll also find our technology being used to conduct an equipment analysis and provide understanding to the various R&D teams. Again, I think that that's testimony to the accuracy and precision that our technology and platforms can offer, and the consistency and reliability as well. When you look throughout the teaching component of the industry and the fitting, we've got partnerships and relationships with many of the best fitters and teachers in the game. Our advisory board currently tops about 62 of the best teachers and fitters in the industry, and we're very proud to have established those relationships over the years. And again, I think that that speaks to the reliability, accuracy, and quality of the products. So without further ado, let's get into sharing just a few of our products with you. We offer three main hardware devices. You'll notice that the GC2, which was our original unit, is not listed. We have moved to a point with GC2 where we are sunsetting that product. So over the next few years, you'll see that product phased out of our portfolio. But our three primary products carrying forward are obviously GC Quad. The pricing that's listed on the page is all in the United States. And the difference between GC Quad and GC3 is the comprehensiveness of the club face information that is offered, as well as the putting capabilities. When you look at GC Quad, it has a couple of unique feature sets that allow us to drive accurate and precision data capture that are unique to our technology. Just a year and a half ago, we launched the GC3, which is designed as a personal launch monitor or a consumer launch monitor. Our kind of view is that the GC Quad is the perfect device for a teacher or a club fitter. The GC3 is perfect for that everyday golfer that's maybe not looking for the depth of insights as to club face information. And then we also have our GC Hawk, which is an overhead mounted fixed position unit. It does have multi-sport capabilities. Right now we have soccer available in our software ecosystem. One of the nice things about the GC Hawk overhead system is that it enables the largest strike zone. So it's about a 4-foot by 2-foot strike zone where we can capture shots from, which is convenient for folks that may not have as much golf technology aptitude as others. And then it also allows us concurrent strikes from righty and lefty. So with any of the ground-based portable units, sometimes there's a requirement to readjust the unit when switching back and forth between a right-handed and left-handed player. The overhead mounted units allow us to do that seamlessly. And that device is really kind of targeted for gameplay and simulation and gamification. When you look at our software, we have two main software platforms. Both of these were launched within the last 2 years. FSX Play is our simulation and gamification platform. It's built in Unity graphics. So when you look at the graphics quality of the user experience in FSX Play, it's built in the same graphics engine that some of our competitors also develop in. And it's considered largely one of the best graphics engines available in the industry. And you'll notice an enhanced UI and UX. We're still building out feature sets within FSX Play. So that product is not fully mature, but a very close in a very close amount of time here. That product will be at parity with our legacy product, which is not up on the screen, which is called FSX 2020. We also have FSX Pro, which is designed more for club fitters and teachers. This is going to give in-depth analytics as far as performance analysis. One of the nice things about FSX Pro is it is available on an iPad, as many teachers and fitters would prefer to use a tablet modality for communicating information with their customers. And once again, the purpose of this platform is to provide in-depth analytics for performance analysis over shots that are hit in a session. One thing worth mentioning is our leagues. This is one component of the FSX Play platform, which was recently brought online. We have been one of the leaders in the application of virtual leagues since its inception. All of that was hosted on our previous legacy platform, FSX 2020. The leagues component was added to the Foresight FSX Play product this last year. Something that we're very proud of is our relationship with the Omega Masters and the Esports Golf League. This is a partnership that we announced and launched last year. It's a unique opportunity for players to be able to compete in a simulator format. And the winner of that simulator contest actually received an invitation to play in the Omega Masters as a contestant, not just play in the practice rounds of the Pro-Am. So something that's kind of unique, and we'll see a lot more of similar sort of activations in the future as esports, gaming, and virtual golf grow. When you look at our products, we offer two different types of simulators. We offer a simulator in a box, or sim in a box product. Price range in US dollars ranges from $9,000 up to $35,000. The nice thing about the sim in a box packages are that it's a pre-bundled solution, so there's already some pricing benefit baked in to the cost of the kit. It is a simulator solution that shows up in a pallet at the customer's door. Fairly easy to install, usually takes less than a day. And we have three different expressions of that, that as far as hardware, that allow us to basically address any space requirement. And then the other option for customers is a custom simulator offering, which we can customize the elements. We have various integration partners that we'll mention in just a moment, that we can also bring into the experience. We offer design and install services. Typical timeline is a few months on design and all of the mechanics needed to customize the design and then deliver the simulator. When you look at programs, we have three programs that we've introduced over the last year that have support different channels. We do have the Greengrass program, which is designed to support club managers, golf professionals, golf teachers, and golf fitters. It offers preferred pricing to accredited facilities and professionals. It also offers them a referral pathway for any business that they refer through their members and patrons. And it gives them opportunities to sell the product and realize some upside from that. And one last point to make on the Greengrass program is that as we see virtual golf become more and more prominent throughout the industry, course licensing is a conversation that more and more operators would like to have with us, and it creates some interesting revenue streams for various operators that are looking to improve the bottom line. We also offer a college program that is for all major NCAA, NAA, and NJCAA programs. This once again offers preferred pricing to the various programs, as well as booster benefits throughout their booster network. And we have partnership opportunities through a revamped college program that we'll be announcing soon with other of our Vista brands as well. And then lastly was a program that we announced just this year called Up Next. This is our junior player development program. We've got over 500 participants, and it's growing very quickly. Once again, preferred pricing and program benefits for those that participate. We have various special activations that we'll conduct throughout the year that all of the program participants will be asked to join. And we have established partnerships with multiple junior golf tours in the space. So when we look at providing technology to the game's future, it's something that we have a lot of energy behind, and we're very proud of the efforts that we've made in the junior golf space, specifically over the last year. Well, lastly, when looking at our portfolio of partnerships, we've been able to announce a couple of key partnerships just in the last year. Topgolf Callaway Brands obviously has been the most significant, and we are looking forward to integrations in partnership with all of the Callaway Topgolf brands. You'll be seeing more about that over the next few months as that partnership matures. We also announced a partnership last year, and we'll be launching an integration soon with Sportsbox AI, it's a markerless motion capture platform. Creative Golf 3D and E6 Connect are simulation platforms that our devices are integrated with. Swing Catalyst, I think a lot of folks are familiar in the teaching and fitting space. Swing Catalyst is a force and pressure platform that evaluates, how people's force and pressure in their feet are captured dynamically through a swing sequence. InRange is a driving range entertainment operator, and PinSeeker is a community-based skill contest in which all the contestants can participate in a prize pool. You'll see a number of new partnerships and integrations announced through the end of this year. We're working on a multitude of them, actually, and we're very excited about where these partnerships will help take the brand and help kind of build the future of technology in the golf space. When you look at what makes us different, this is a part of the presentation where I'll soon hand it over to our Director of Education, Liam Mucklow. There are 5 main points I think that are worth considering, though. Versatility. So when we look at the versatility of our products, whether you're using putting or whether you're using it for swinging clubs, the accuracy and the precision in the capture environment doesn't change, whether you're indoors or outdoors. The way that we capture the data, the way that we process the data, and the way that we report the data does not change. So you'll see consistency from environment to environment, and the same type of accuracy and precision that you would see in swinging clubs, you'll also see it in the putting applications. I mentioned accuracy and precision in these 5 bullet points. There is a nuance that's slightly different. Precision is the ability to measure something very granular units of measure. Accuracy is whether those measurements are actually right or not. When you look at the accuracy and precision of our technologies, once again, going back to our R&D relationships with the various OEMs and governing bodies, there's a reason why they utilize us throughout their R&D programs. It's for the accuracy and precision that we can boast. When you look at reliability, that's obviously very important to any commercial operator, that the technology that you have is going to work day in and day out and not miss shots. For all of us that have worked in the teaching and fitting space, there's nothing worse than when a customer hits a shot and you want to see the data from it, and unfortunately the technology did not capture from that shot. When you look at our reliability, our capture rate is as high as any other technology currently available. And then lastly would be durability. Once again, speaking about the industrial design of our products, we don't use acrylics and plastics in our manufacturing process. We use materials and components that are designed to last. Our GC3 and GC Quad devices are designed to withstand a direct ball strike up to 80 miles an hour. And for those that may have seen a couple years ago, one of the OEM partners did some marketing with their PGA Tour players, and Rory actually toe shanked one into the machine and it kept working. So it's something that we like to mention as a testimony to the durability of the product. With that, I would like to hand it over to our Director of Education, Liam Mucklow, and he'll be able to share with us some more information about both our technology capture system and how it's different than competitors. Liam, take it away.
Awesome. Thanks, Tim. Appreciate it. My name's Liam Mucklow, originally from Edmonton, Alberta, Canada. I'm a two-time national award winner with the PGA of Canada, and have been fortunate enough to spend time training a couple thousand golf professionals and fitters on technology operation and implementation best practices with their business. Let me just queue up my portion of the presentation here. Okay, so there's there's my quad. This was one testing. I was actually have quad serial number 5. And what I want to share with you guys today is a little bit about, what's actually going on under the hood. How do we get that precision, accuracy, consistency? And then share with you some of the key differentiators from both the club data, from the ball data, and how we apply them to help golfers get better faster, be that a client in a lesson or a home user working on their own game. So the very first thing that we have to, or should have a basic understanding of is, stereoscopic vision. What is stereoscopic? Well, stereo means two. And we can see here, like with this example, when something is out in front of us, we're able to track that object with both of our eyes. I love this image because I think it really easily communicates how it started with GC2 is working very similar to, to the human's visual system, right? We're tracking one golf ball with 2 cameras. People are tracking one object with 2 eyes, and that's how we get, depth perception. So what does this allow us to measure? Well, it allows us to measure club velocity. Now, velocity is a vector measure. That means, it quantifies both the speed and the direction, and we'll break those things down to make them easier to digest. But that is a 3D metric. We've got club orientation, and we're going to talk about some of those things as well. A club face projection, impact point, ball velocity, and ball rotation. So there's 2 main types of launch monitors. There's optical and there's radar. So what we've got on the left is a ball capture sequence from a single camera inside the ball. And it becomes very easy to see, just the resolution. When I first saw this image, it really blew me away how clearly I could read Titleist and how well I could see the rotation. This was also, very useful in me understanding how our GC Quad was able to measure spin axis so accurately and give us the most consistent data across all environments. On the right, we have a raw radar signal. And, the way this image kind of works, the way to interpret is you see on the left-hand side, I've got, velocity going up the vertical axis and time across the horizontal axis. That upward arc you see on the left-hand side, that's the club. So you can see the top is traveling at a higher velocity. That's the toe. The bottom portion of the heat map arc is the heel. It's not traveling as fast. You get to that vertical line about 1/3 in from the left-hand side, and that's the collision time. And up top, you can see the ball emerge. Obviously, it's going faster than the club. And radar systems have to interpret this data and then turn it into presentable, digestible information. You can see some of the key differentiators there in the bullet points down below. So let's talk a little bit about measuring the club head. Now, the image on the left actually comes from the patent filings from Wintris Technologies, one of the companies that was acquired in the formulation of Foresight Sports very early on. And I think it's important for us to understand, when we look at our old HMT image there, you see the 2 cameras are pointing back towards the club. Now, we don't actually see the club face. What we see is the fiducials that are placed on the club face. And the infrared camera picks up the reflection across all different lighting environments that allows us to accurately measure the face plane. That's a 3D measure. The red arrow on the left is showing us the face normal. And then, what we do on the software side is actually break down these 3D measurements into more digestible one-dimensional measurements. This is a single capture, one swing for image is captured by a single camera in the GC quad of a driver. And so you can see, as we get farther towards the bottom right, we can see those 4 dots, the 4 fiducials on approach to the ball. And then, of course, you can see where collision would be, and it tracks it even a little bit post-capture, post-collision, sorry. So what do we measure? Well, we've got club head speed. That's a pretty simple one, very, very simple measurement, as is just the the software understands the frame rate the cameras operate at, and the distance in between each of those images allows us to very accurately and consistently measure club head speed. It's one of the velocity components. Now, we also see from here we've got club path and we've got angle of attack, right? So that was for club velocity, the speed and direction which the club head is traveling. We're also able to very easily and accurately characterize the loft on the club, right? And so that's measured for 90 degrees in relation to the ground plane. One of the great things inside the quad is that it actually has built-in calibration to adjust and normalize to uneven surfaces. So when you put it down on the driving range, if the grass is uneven, it will normalize to that. Of course, another component to the face projection is our face angle. And then, of course, our lie angle. And the way these 3 come together is what gives us the true 3D face normal projection. We've also got closure rate. I like to also refer to that as our rate of change of face to path, and impact point, which is arguably the most important measurement to have a very high level of accuracy. When we look at the best players in the world, we see massive differences in club head speed. We see club pass that could range anything from about 6 degrees in to out to 6 degrees out to in. But that really one consistent signature is center face consistent impact point. So I want to kind of drill on this a little bit more. And, the impact point measurement, we'll go back to the older days with the GC2 HMT, is really what converted me from being a radar user into an optical user. I had a former Masters champion come in who was struggling heavily with their driver, and we were on one of my radar systems, and in an indoor environment, and the software kept showing that they were hooking the ball about 300 feet right at the target. And the player keeps looking around at me going, Liam, like, that's not what's happening. And I'm kind of freaking out at this point in time, going, oh man, this ain't good. I got a Masters champion who tells me my tech is wrong, and I'm, not really sure what to do. And, thankfully our Canadian Foresight rep had installed a GC2 HMT in one of the bays in my indoor facility. So we walked down the hallway, we went in there, the very first shot he hits, I see this red dot on the heel, and it's a slight fade, that ends up in the fairway, but it's spinny, it's short, it's all this stuff. And he looks at me, he says, that's exactly what I'm doing. And, that was an eye opener for me. And next trip down to the Titleist Performance Institute, I stopped into Foresight Sports and needed to learn more about, how this worked and why was it accurate. And, that's where I learned about the spin axis. We're going to talk about that, and also this impact point stuff. So having this level of accuracy and consistency in the commercial environment, or for passionate golfers, I just think is so important. The face angle, again, I want to touch on this. When we look at the way Foresight Sports measures face angle, it's going to present, I like to think of it as also presenting not the face plane, but sort of where's the sweet spot pointing. And I think that for a lot of radar users that don't truly understand how it makes its calculations, they can be misled, particularly when we get to the curved face clubs. So, if I have a driver with the bulge and roll, if I move 1 inch off the center, we're between 5 and 6 degrees change in face angle. So with that, with any of the radar devices, if I have the sweet spot oriented directly at the target, but I strike it 1 inch towards the toe, it's going to tell me, my face angle was about 5 degrees, 6 degrees open. And when the golfer doesn't understand that it's not the sweet spot was fine. It was because he struck it off the toe. They're going to get into this cycle of making unnecessary attempted corrections, and it can actually lead them down a rabbit hole where they end up getting worse. So I think you know, being able to differentiate, hey, like this is where you pointed the face plane, and then see that dot to know, hey, this is where you actually hit the ball, puts us down a better path for applying the data that we get from our technology. But the same thing is true on the vertical axis. If I have a 10-degree driver and I return it, we'll call it like a normal position, so the sweet spot has 10 degrees of loft on it, but I strike that ball half an inch up the face, it's going to tell me that there's a roughly 13 degrees of loft. The opposite is true. If I go an inch low, it's going to tell me I've got 4.5 degrees of loft. And that can lead to the coach, fitter, golfer, again, making, we'll call it a false positive correction. They're making adjustments that don't need to be adjusted based on lack of understanding of how the radar system presents information. This will tell you the true inclination of the face plane and then segregate the impact point so you can consume all of the data and have a clearer picture of exactly what's going on. I think when it comes to performance of irons, whether you're amateur or professional, I think one of the biggest opportunities to improve control is to go through your set club by club and make sure that you have, a roughly neutral lie angle, something within 1 degree toe up or down. And we'll get into it here in a second, but that goes a long way to ensuring that the club face projection truly is downrange at the target. You can see here, with this image right here in the center, when we do have a lie angle that is not neutral, it's going to alter the actual club face projection. And as we have more loft on the club, that's going to increase the amount of offline projection you get due to an incorrect delivered lie angle. Now, when we get a lot of golfers in, if they have, let's say their entire set, they're delivering about 3-4 degrees toe down, because there's different loft on every club, they're actually going to have a different amount of face closure for every single club in the bag, essentially a different release timing for every single club on the bag in order to have that face oriented in their intended start direction. Golf's hard enough. We don't need to have 13 different releases. So yeah, let's get our lie angles dialed in. All right, let's get in here to talking about a couple things to do with the golf ball. Now, again, this this is a huge one. This and the impact point are, what converted me away from being a radar user. And at the end of the day, when we can accurately measure the axis tilt, that gives us the opportunity to very accurately calculate the amount of curve on the ball, as opposed to a radar system that's going to rely on curvature of the ball to then attempt to calculate spin axis. In the outdoor environment, say that's fine, but when we get in the indoor limited flight environment, there's not enough distance for the ball to fly for a radar system to accurately be able to extrapolate spin axis. So they're getting better, but still what they have to do is extrapolate, calculated face angles, calculated impact points, get a predictive gear effect engine. And it's a very, very, very difficult thing, basically impossible to consistently accurately predict it. The ability to measure the axis tilt is what's going to give us the same ball flight information in the indoor and the outdoor environment. And I think this is, particularly critical for, golfers that train indoors, seeing the same results outdoors of the work they put in indoors. This image blown up really gives us a pretty clear, simple way to understand exactly, how simple it is to measure axis tilt. I love when we started to show this image in the in the live seminar environment. It's like, okay, well, what kind of shot shape is it? And I think for all of you out there, we can see on the left-hand side, bottom left corner of the image, that it's a right-handed driver. And it's pretty clear to see the axis tilt rotation by looking at the Titleist logo that this was a draw. Now, this thing is super important, the barometer. So having an onboard barometer allows the quad to adapt in a much more accurate way to different environments. If when all we do is go with altitude and temperature, and we eliminate pressure, we eliminate key environmental aspects that actually have a significant effect on ball flight. You can also see the accelerometer up there with the pitch and roll. The barometer, axis tilt, all of these things roll in together to give us such a high level of accuracy to make it the most trusted launch monitor on the PGA Tour, the highest form of golf competition in the world. And it's what leads to the accuracy of the ball flight model. So what I've got up here is a chart where in the outdoor environment, we used a industry leading radar product, we used a GC quad, and we used a Bushnell laser rangefinder with team downrange doing grid and pole testing. So they would measure exactly where the ball landed, both distance from where it was struck and offline from center. And if you go down to the bottom right, what we can see is in the blue, the GC quad was within 1.5% accuracy of carry distance over an average distance of 151 yards. So as accurate as a laser rangefinder. If we go to the right, we look at a radar technology that is tracking the full flight of the ball. For our ball flight model to be within 0.4% of the percent error of a full range tracking system absolutely blew me away. And then when you take a look at the middle column, where certain radar products have a normalization feature where they attempt to eliminate the environment by extrapolating calculations based on the first 30 meters of ball flight, it was actually quite surprising how much the accuracy degraded. So, that axis tilt, so there's a lot more going on. We didn't touch on some of the basic stuff, but combined with the barometer is a big part of what gives us that, the most trusted ball flight engine in the golf world. So I am going to stop sharing there and kick it back over. If there's any Q&A.
Yeah, so Liam, I think, when you mentioned the face normal on irons and being able to deconstruct where the ball started relative to the components of face delivery and the X, Y, and Z axis, that's one huge component that for me in my club fitting time was a huge differentiator of being able to break down, okay, the ball started off 3 degrees to the right, but the leading edge of the club was actually 1 degree closed, and the toe of the club was digging in 4 degrees, and you hit it off the toe, and it was a hybrid. And so being able to deconstruct that down into X, Y, and Z is a crucial element, in my opinion, for accurately assessing player, club delivery. And it's something that really only the premium optical system can give you, from my experience. And the other component you mentioned earlier was the spin axis tilt, and being able to measure spin axis tilt the same way, regardless of what environment we're in. So the way that we capture that is not changing indoors or outdoors. And you can understand, from looking at that image of the launch sequence, exactly what the axis tilt is that's being measured. And so you don't end up with those disconnects in the simulator environment specifically, where you hit one that was a little fade, but then you look up on the screen and it shows a pull draw, or vice versa. And so I think that that's a really, really crucial element. We get asked the question a lot, why have so many PGA Tour players switched from radars to specifically to GC quad? There are a multitude of answers. The LCD display, I think, is one. Being able to see the data on the device itself without having to hook it up to a phone or a computer. The convenience of that when you're on the golf course, obviously, is incredibly useful. But when you look at the measured spin axis, for folks that are looking at the club face delivery, being able to break the club face delivery down in X, Y, and Z, when you start, peeling layers of the onion back, I think we find that there are multiple reasons why different folks use our technology. In your teaching in fitting, What feature do you find the most helpful as far as a feature that's differentiated to other technologies?
Well, the face measurement and axis tilt, and for some of the people out there, you listen to Tim and I go back and forth. We've been at this and in the weeds for a long, long time. So if you feel like you're drinking from the fire hose a little bit, first off, I would encourage you to go to peak.foresightsports.com. There's a free online education program where you can, take time to get understanding for all of this type of stuff. But just similar to what you were talking about with the hybrid, being able to deconstruct, all the parts of the collision allows me to make much more educated decisions and deliver better results faster than other people. I wanted to actually share one of the cool PGA Tour stories from last Zurich. It's neat to see, so high level of in the act of the ball function. The players on course are actually using it as an evaluation tool for how well they're estimating the wind. Right, so you can picture I've got a player I work with. We laser the flag. We're 188 yards out, and he thinks it's playing 180. Him and his caddy are estimating 8 yards of downwind. He hits a shot on the quad. The quad says 178. We get up to the pin. We pace it. He's 5 yards short. The pitch mark is 5 yards short. And he knows he missed their win by 3 yards. So there's so much cool stuff that goes on out there. I mean, gosh, just the ability to bring a device with you on course and accurately compare what you're doing in your home simulator or at the driving range, of course, hitting the same shot. Am I performing the same?
You mentioned earlier the barometer, and the barometer is such a huge component, I think, that kind of goes unnoticed. The best technology, when it's working properly, nobody really knows what goes into creating it and making it. But we found this out at the U.S. Open a couple years ago at Torrey Pines. The elevation of the golf course didn't change, obviously. And here in San Diego, the temperature stays a nice balmy 73, at 10 in the morning and in the afternoon all day long. So the elevation and temperature did not change from morning to afternoon. The only element that did was the barometric pressure. And we were seeing a difference for most of the tour players of about 7 yards of carry distance between playing at 10 in the morning versus 3 in the afternoon. To your everyday golfer, maybe 7 yards, is lost within the noise of their normal variation. But for a tour player, that's clearly the difference between winning a tournament and losing a tournament in many cases. So
Yeah.
the barometer functionality, I think, understanding how that's utilized. A couple years back, we had a PGA Tour player at the Waste Management who was noticing that the carry distances on the machine were all messed up and was questioning the accuracy of the data. What we realized is that it was 55 degrees out that morning, and the player had their quad sitting in their hotel room all night, and it was 7:30 in the morning, and the quad hadn't acclimated to the environment. After about 10 minutes, 10 minutes of the barometer acclimating to the environment, all of a sudden the carry distances looked, right on, bang on the money. So understanding the technology and the components of it and what goes into producing the data that you see, I think is crucially important. I think that's a general statement I would make across all platforms. Understand what your platform that you're using is really good at, understand where it's challenged and where it may struggle a little bit. And understand some of the elements that go into creating that platform so that you can draw better insights out of the data that you see. I think we've got,
Tim, I'm
do we
just
have
yeah, just looking at the Q&A. We've got one question specific to putting, which we didn't touch on. So I was going to see if you could maybe go through how long do you track putts and with which products? So what of the products, which ones are able to characterize putting?
Yeah.
And just speak a little bit to that. Thank you.
So great question. The putting application for Foresight technology is something I'm very familiar with. Prior to my time with Foresight, I was very fortunate to have worked with a number of PGA Tour and LPGA Tour players specifically on putting. And the device and platform that I used exclusively for all of that was GC Quad. So when you look at which of our products track putting, all of them actually track it. So when you look at GC3, you'll be able to use a GC3 for putting simulation, but it's not going to give you the level of data that you would get from a quad when you're talking about launch spin and launch angle and some of the club delivery aspects. So the putting application for GC3 is more designed to power simulation than putting analysis through, like, coaching and fitting and teaching. When you look at the Hawk system, again, that putting capture environment with Hawk is designed to support simulation. So would you use that to perform a lesson? Maybe not with a tour player. For the average golfer, you probably would be able to use it, but for a tour player where having that tolerance cut down the tenths of a degree matter. When you're looking at quad, that's going to be the most capable of our devices when it comes to driving in-depth analysis for teaching and fitting. And when you look at, how long of a putt, first and foremost, we're capturing a phase of the delivery of the club. The data that's being reported is being reported right at the moment of impact. But then we're also capturing a phase of the ball launch where the ball is launching through the air and then hitting the ground and starting to roll. So we're capturing both a phase of the club delivery and a phase of the ball launch. When you're looking at length of putt, length of putt as far as the quality and accuracy of the data, if you end up getting into a 60 or 70-foot putt, that ball may be airborne for the entire duration of the capture sequence. So we may not actually see the ball hit the ground in that anomaly. But for most putts that are under 30, 40 feet, we're actually capturing the entire ball launch until the ball hits the ground and starts to roll. So it's a full capture interval. Hopefully that answered your question there, Elvis. There was another question here, Liam. How far away to measure club without markers? All right, so club without marks. Obviously, this is something that we get asked a lot. A lot of folks find the fiducials on the face as a pain point. We're working on it. I mentioned earlier that we have relationships with the R&D departments at various club manufacturers. It's something that we're collaborating on with them. We're very, very close. Do we think that the fiducial-less capture environment will have the same level of resolution, precision, and accuracy as a fiducial environment? Probably not. We're still working on it to try to fine-tune it. But yeah, suffice to say that we understand that some folks, have a challenge with using the fiducial stickers, and we're working on a solution to solve for that. So I would look for that in upcoming products or updates that we make to the system. We're not there yet, but we're getting there. With that, I guess we can open it up just for general questions if folks have any. Certainly appreciate the time spent thus far, and hopefully we were able to characterize some of the business and brand, as well as the way that our technology actually works and how we're different.
Tim, in the Q&A, there's another question there from an anonymous. How about ball normalization?
Ball normalization, great question. So when you look at ball normalization, I'll obviously, feel free to chime in here, Liam. When you start looking at the aero packages of how balls with different dipple patterns fly through the air, and I look at how some of our competitors have normalized ball data, my takeaway is that the normalization schedules that currently exist are very incomplete. So when you consider that the same ball taking off with the same launch characteristics could fly 8 to 9 yards differently downrange, putting all balls in a premium hardball characterization or category, to me, is an incomplete characterization of the ball being used. I think the industry has gotten used to ball normalization tables because they've been around for a while. But unfortunately, to do it right would take really developing a ball flight equation for every single ball that's in the marketplace. I don't know what your thoughts here are, Liam, but I struggle with normalization schedules. I understand that they're very helpful for folks, but I also find that in that effort to make things a little bit easier, and normalize, we end up losing a lot of resolution and precision in the data. Where would you say, Liam, that you fall on the concept of normalization schedules for ball flight? Liam, are you able to hear me? He might be having problems with his audio. I think he may be. Well, in any event, when it comes to ball normalization, it's something that we've definitely conceived. It's something that we can execute against. But when we look at it, we feel that normalizing and putting things in these very broad buckets of, premium ball, premium hard ball, et cetera, that there's a lot that's left out of that normalization schedule, especially when you start considering the differences in aero between one ball and the next.
Tim, I have Steve who's put up his hand. He wants to ask a question. I'll just
Absolutely.
put it on. Okay. Steve, go ahead. That's Steve Fluke. We'll wait for Steve to ask his question.
Yep, and if it's easier, Steve, you can dump the question into the Q&A in text format, and we can answer it that way too if you're having problems with audio.
I believe there's another question coming through on the Q&A as well.
Got it. Share, how much challenge is brand to your sales effort, and what do you do to challenge it? We share a common competitor. How much of a challenge is brand to your sales effort? I'm not quite sure where that question is targeted. Challenges your brand to your sales effort. I would say when it comes to our current sales efforts in the space, 4 or 5 years ago, pre-pandemic, when golf technology wasn't as prevalent through the industry, when we didn't see as much off-course participation, and you look at the efforts and successes that our competitors have had in the marketing space, I don't think as many people were familiar with our brand or products. With PGA Tour utilization, growing over these last couple years, with adoption throughout all of the major, teaching and fitting applications in the industry, I think that we've established a brand at this point that, competes against any of the technology brands. And, as far as how efforts that our competitors have made in this space have challenged our current brand, I would say that, we hold a unique position in that we're premium optical. It's manufactured here in the United States. That's a unique component of our brand. And it makes it very easy to position that against our competitors currently in the marketplace. So, when you look at our successes in the sales channels, the company's growing exponentially. I would say in general, when you look at the marketplace, the area where we're seeing the most growth is home simulator sales. I don't think that that's a secret to anybody. The volume of home simulators that folks are putting into their homes, that country clubs are putting into their facilities, us and our competitors have never seen this amount of growth before. So it's very encouraging where golf technology is taking the industry. Any other questions, folks?
If anyone has any questions, you can use the raise hand function at this stage.
Great.
Nobody yet? Okay. Great.
Nobody yet. But in closing, I guess, Abu, if you're comfortable, obviously, if you have any questions that come to mind after the seminar is over, feel free to shoot them over to Abu and his team, and they can get them over to us, and we can have a direct dialogue to answer those questions. As Abu mentioned, this webinar has been recorded, so there will be a version of it available that you folks can review. Thank you, everybody, for your time. Speaking on the behalf of the team at Foresight, for all of us, for all of you that are on the webinar that are customers, thank you for your business and support. For folks that are considering technology for your applications and teaching space, in entertainment space, we certainly hope that you'll consider our technology. We're very confident in how we can deliver for you in your commercial applications. Looks like we do have one more question here. I just saw Hamza Yunus raise their hand.
Oh, I think they might have been clapping.
Oh, gotcha. I'm not up on my emojis. But in any event, we do appreciate the time taken this today by everybody on the webinar. We look forward to another one of these sessions again. Thank you, Abu, again for setting this up. And we hope that you folks enjoy your Foresight products that are using them.
That's
Thanks
great.
everyone for joining.
That's great. Thanks very much, Tim, Liam, and everybody for joining the webinar today. As Tim mentioned, any questions for Foresight, please direct them to myself, and you can find our details on the website. And as Tim mentioned as well, the webinar will be available as a recording on the GBT website, but it'll also be pushed out through all our socials as well, through the Foresight and the GBT socials too. So yeah, great to have you guys take part, and we'll see you again soon on another webinar. Cheers.
Thanks everybody.
Have a great day, everybody. Bye-bye.
Bye, guys.